Chicago Public Schools Student Science Fair Incorporated presents the 64th Annual Student Science Fair, March 20th through the 23rd, 2014, at the Museum of Science and Industry. The theme this year is Bringing STEM Home. This presentation hopes to help you and your student understand that science is not just a subject, but a way of looking at our world. To supplement the teacher's information to ensure that the student develops their project, and to help the parents understand their role in supporting their child's project and their fair preparation. Why is science important? Which describes your child? Do they enjoy participating in science fair? Do they participate because it's required? Or do they enjoy not participating at all? Now consider this about your child. How many like to cook or bake? How many enjoy playing computer or video games? Do they like building with Legos or designing origami? How many can calculate an athlete's statistics just from memory? Well, we have to teach our children to be excited, interested, and explorers of all aspects of science. Why is science important? Science utilizes reading, writing, math, critical thinking, and creativity, which makes it a much more challenging subject. If you wait until high school to focus on science, children are already behind. A science curriculum helps children appreciate the importance and role that science plays, from the beginnings of life to food nutrition for sustenance, to the environment, to everything. In Illinois, science is tested in only 2 grades, 4th and 7th, whereas reading and math are tested annually in grades 3rd to 8th. So why do a science fair project? Science fair is the time for your students to express themselves through scientific research, artistic flair, creativity, and their oral presentation that exhibits confidence, knowledge, and articulation about their subject. Although everyone doesn't advance to the next level, participation in any science fair advances that child's exposure, experience, and excellence for a brighter future. STEM areas allow students to develop and build interests in science, technology, engineering, and mathematics, while increasing their preparedness and career marketability for the 21st century. Student Science Fair also offers monetary special awards to students in many topic categories. Student Science Fair also provides scholarships to graduating seniors that have participated in a regional, city, state, or international fair. The application deadline is April 4th, 2014. There are also research grant programs. The Mini Grant Program awards a maximum of $100 per semester or $200 for the year, and that's for students in grades 7 through 12. The Maxi Research Program awards a maximum $500, and that's for students in grades 9 through 12. All equipment and supplies become the property of the school when the project is completed. Also, the grants are evaluated on the basis of scientific merit, scientific approach, and the potential for further development. Please refer to page 99 in your handbook for the calendar of events. The grant application deadline is November 15, 2013. Save all receipts for reimbursements. President Obama has also expressed the need to educate students in the STEM areas by developing an initiative for educators and businesses to produce greater numbers of children entering these fields and increasing the exposure of these subject areas to underprivileged and underrepresented students. Moreover, the White House hosts an annual science fair to showcase national winners in science, robotics, and technology. When students perform a science fair project, they use the scientific method, learn problem-solving skills, learn organizational skills, improve processing skills, discover several solutions to solving problems, build self-image and improve self-esteem, implement technology, and practice library research. There are several project distinctions, notably model building, for example, the famous volcano, or a demonstration where a student sets up a circuit board. There are reports or posters. All of these teach students observation, research, construction, design, and manipulation skills. But the most comprehensive is an investigation. It asks the question, what should I test? From an investigation, students learn observation, measurement, prediction, inference, classification, control, variable identification, graphing, data table construction, experimentation, research, writing, display board design, and public speaking. Student Science Fair offers a myriad of topic distinctions. Please choose the one that your student is interested in exploring. For the experimental process, encourage your students to explore an interest, a fascination, or an idea that raises a question that they would find stimulating to answer. Please refer to pages 2 to 6 of the handbook for this description. There are two types of groups, the control group and experimental group. The control group is the study group that is used for comparison. It is not changed or manipulated in the experiment. The experimental group is the group that has something done to them. The something in this case becomes your variable. There are two types of variables, independent variable and dependent variable. The independent variable is when the scientist manipulates or changes something in the experiment. The dependent variable is the response or effect of the manipulation. For example, let's study the effect of different concentrations of sugar on the growth of onion root tips. Our control is tap water without sugar. The experimental control is the same variety of onions grown in sugar with different concentrations. The independent variable is sugar mixed with water at 10%, 50%, and 90% concentrations. And the dependent variable will measure the length of the root tips in those different concentrations. The 63rd Student Science Fair introduced the design project. Student designs and tests a new product, algorithm, model, or procedure. For more details, please refer to a comparison of the scientific method and the design process on pages 2 through 6 of your handbook. The design process is very intricate So please refer to pages 2 to 6 for this graph. There are also other product distinctions. For example, the symposium, which is for high school students. This is an original research and 4 copies must be submitted. The endorsement deadline is November 8th, 2013. And please refer to pages 40 to 41 of your handbook for more details. An essay for students in grades 7 through 12 is also another area that some students may be interested in. The topic this year is It's an Ice Day for Science. The essay must be between 1,200 and 1,500 words. Refer to page 41 for more details. There is also a cover design contest. This is for students in grades 7 through 12, and you do not have to have a project, paper, or essay to participate. The theme is It's an Ice Day for Science. Please refer to page 42 of your handbook for more extensive details. Monetary awards are available in all of these areas. A successful science fair project is the students' work. It's an understanding of the science area that they're interested in. It's carefully planned, not rushed. It's original and creative and has their ingenuity involved. It's a controlled test with one manipulated variable. It draws conclusions from repeated trials. It's accurate, valid, and has correct observations. It uses the metric system. It has proper safety measures taken. And it gives credit to everyone that helped. The display board is sturdy and able to stand alone. It meets measurement requirements. Its simple, well-stated title is present. It has neat lettering. It includes the scientific method. It includes photographs, charts, graphs, and data tables. It represents the best of the student's ability. And lastly, your science fair project is not only a report. It is not a plastic model. It is not an enlarged model or drawing. It is not a weekend chore. It is not 2 or more posters. And it is definitely not done by a parent or teacher. Please refer to Elizabeth Copper for any questions regarding science fair help. Which graph would you suggest that your child use for the following data? If they have to calculate the mean of different trials, use a bar graph. If they want to compare the length of growth over a certain number of days, use a line graph. If they'd like to see the percentage of different chemicals, say in the atmosphere, use a pie chart. Judging criteria. Judges will ask your child the reason that their topic was chosen. How or why did that child arise at their hypothesis? The controlled experiment with at least one manipulated variable should be present. The number of trials performed. Quantitative results, actual measurements should be noted. No qualitative results, so don't say the onion root tips look longer. Give actual measurements. Metrics should be used with the correct abbreviations. Data recorded regularly. Results presented in a table, chart, or graph. Results should be related to the hypothesis. Conclusions should be related to the initial questions or problems asked. And calculations, when applicable, for the mean, standard deviation, any standard errors should be noted, or other statistical measurements. Science is measurement and reproducibility. It is a fundamental scientific truth that no measurement is ever 100% accurate. Judges will also read the review of literature, or your paper, which should be written in the student's words or paraphrased. The review of literature should be proofread and edited by a teacher or parent before being submitted to the science fair. The research must be cited if copied from an author. Anything not cited is plagiarism. Therefore, all paragraphs in your review of literature should be cited, except where data is collected, results are drawn, or in many instances, the conclusions that are drawn. Judges like to see photographs, so display them on your board. Always remember, honest answers to questions impress judges more than making up a response. Students must have confidence in themselves and knowledge about their experiment, which will allow them to feel more comfortable during the judging process. Speak clearly, slowly, and deliberately. Talk to the judge, not the floor, ceiling, or wall. Stand, don't sit. Dress for success. And do not chew gum or candy. Remember, the first impression is the most lasting impression. Parents, how can you help? First and foremost, do not perform the experiment for your child. Help your young scientists understand the purpose. Learn critical thinking, problem solving, research, and much more from this experience. Understand that science is all around us. Take time to develop the project, not over the weekend, but for at least 4 or more weeks. Support your young scientists. Visit the library. Listen to their oral presentation repeatedly. Give suggestions, criticisms, and praise. Ask questions so that your young scientist actually thinks more about the project. And reach out to the teacher for assistance. Read the handbook and contact Student Science Fair as needed. Help your young scientists stay safe at all times by monitoring the use of the following hazards. Please direct all safety questions to Laurel Madden. Your child's project may be disqualified for violations of safety guidelines. Ensure all rules and regulations are followed, especially those dealing with animal experimentation. Make sure the scientific method is followed. So from the abstract to the conclusion, please include that. Keep a detailed and organized notebook. Don't erase your notes, because that can provide information for another part of your experiment, say experimental error. Document the date, the time of day, and everything in a notebook. And consider factors that contribute to experimental error. Note all observations and observe all notes. For your citations and references, the internet is definitely the most convenient source, but there are so many other areas that should be used. Refer to the handbook on pages 30 to 33 for the correct format for your citations and references. And remember, the correct format for sources must be based on the specifications given by Student Science Fair. Your child's science fair experience should be creative. It should develop critical thinking skills. It should be enjoyable. Develop time management skills. Be interesting. Develop esteem and speaking skills. and teach them about the fascinating role and importance science plays in our world. For any questions related to this presentation, please contact Tracy Raoul or Luba Johnson. Thank you and have a great science fair experience.